Alright, so I'm going to go over the constructions for assignment number 15. Here it says we're going to use the segments provided from us for assignment number 14, so I'll be flipping back and forth between the two sides. For number 1, we want to draw CD and then construct PQ, the perpendicular bisector of CD. So what I'm going to do first is just start off with a segment. Then I'm going to go ahead and flip my paper over to look at the length of CD. I'm going to open my compass to the length of CD and then transfer that onto my segment. Okay, so here we have the length of CD. Now I want to create the perpendicular bisector for CD, so I'm going to put my compass point on one end point, open the compass more than halfway, draw an arc that goes below and above. Keeping the compass setting the same, I'm going to turn it around to the other end point at D and draw the same arc from the other side. Now I'm just going to go ahead and line up my straight edge with the points of intersection between the two arcs, and we've created the perpendicular bisector PQ. All right. For number 2, on assignment number 15, we want to draw AB, and we want to construct segments that divide AB into 4 equal segments. All right, so for number 2, first thing I'm going to do is draw a segment. And then I'm going to measure out AB from assignment number 14 by putting my compass point on A, opening the pencil up to B, and then transferring that onto my segment for assignment number 15. So here we have A, B. Now if I want to construct segments that divide AB into 4 equal segments, what I'm going to do is I'm first going to do the perpendicular bisector, which cuts it into 2 equal segments, 2 equal halves, and then I'm going to cut each half in half. So to start, I'm going to put my compass point on A, make sure the compass is open more than halfway, draw an arc that goes below and above, turn the compass around to point B, draw the same arc, and then I'm going to connect the 2 points of intersection so I have the perpendicular bisector of AB. Now what I've done is I've created 2 equal halves, so we can see that 1 half is equal to the second half. Now I'm going to bisect each half so that I create fourths. So to do that, I'm going to put my compass point on A, make sure the pencil is more than halfway, draw an arc that goes below and above, pick the compass up, keeping the same compass setting. Now I'm going to put it on the midpoint of AB, draw the same arc, and connect the points of intersection. So now I have 1 half of a half, and I'm going to go ahead and do that on the other side. Put the compass point on B, draw my arc, turn it around to the midpoint of AB, draw the same arc, and then I'm going to connect the points of intersection for the 2 arcs. So we have the original AB has been divided into 4 equal segments. So 1/4, 1/4, 1/4, 1/4. Okay. Next, for number 3, we want to draw a line close to the edge of the paper. So for number 3, I'm going to draw a line that's close to the edge of my paper. Okay. We want to construct the perpendicular bisector. Now the problem with this is with my other perpendicular bisectors, I go on each side of the segment, whereas here I don't have space to go on this side of the segment without drawing on my table, which I don't want to do. So what I'm going to do is I'm going to create the arcs all on one side. Now the purpose of the arcs is to find a point that is equidistant to the endpoints. So what I'm going to do is I'm going to start off with one setting. I'm going to open my compass more than halfway, draw my arc from one end point, keeping the compass setting the same. I'm going to turn it around and draw the same arc from the other side. So I have one point that is equidistant to the two end points. To find another point, all I'm going to do is change the setting of my compass. So I'm going to open it a little bit further. I'm going to draw an arc, keeping the compass setting the same. I'm going to draw the same arc. So I've created a second point that is equidistant from the two endpoints, which means that both are on my perpendicular bisector, which means that I can now draw in my perpendicular bisector. All right. All right, so for number 4, it says construct segment RP, where RP is equal to 2CD minus 1/2 AB. So for number 4, all right, I'm going to go back to assignment number 14 and measure the length of CD. So put the compass point on C, pencil on D, and I'm going to transfer that to my segment. All right. And I need to do that a second time. So we have 2CD. All right, so there is 2CD. Now I want half of AB. Well, if I take a look at number 2, I bisected AB when I created the midpoint here. So from A to its perpendicular bisector, that is half of AB. So I'm going to go ahead and transfer that on to number 4. I need to extend my line a little bit further. And that will give me RP. So here we have R, we have 1 CD, 2 CD, and then half of AB, which we took from number 2, RP. All right, number 5, we want to construct MN, where MN is the average of AB and EF. So for number 5, remember that the average is we add up the values and divide by how many values we have. So if I add AB plus EF, that's 2 segments, so I'm going to divide by 2. When I divide by 2, I need to construct the perpendicular bisector, because that will give me 2 equal halves. So what I'm going to do is I'm going to first start off by drawing a segment. This is probably going to have to be a little bit longer. Okay, and then I'm going to go back to assignment number 14, and I'm going to transfer the length of AB onto this segment and the length of EF onto the segment. Okay, so from the beginning to this point right here, we have the length of AB plus EF, but I want MN to be the average. So now I'm going to construct the perpendicular bisector of this segment by opening it more than halfway, drawing an arc, keeping the same compass setting, turning it around, drawing an arc, lining up the points of intersection, and constructing the perpendicular bisector. So we want MN, so here is point M, here is point N, where MN is the average of AB plus EF. All right, now for number 6, we want to construct triangle TUV. All right, I'm sorry, we're going to draw that, and then we're going to go ahead and construct the three perpendicular bisectors of that triangle. So I'm just going to go ahead and draw a triangle. And we want to label this TUV. And then I'm going to construct the perpendicular bisector of each side. So put my compass point on V, open it more than halfway, draw an arc, keeping the same compass setting, compass point on T, draw an arc, and we have our first perpendicular bisector. Okay. For the second perpendicular bisector, I'm going to put my compass point on U, open it more than halfway, draw an arc, keeping the same compass setting, put the compass point on T, draw another arc. We're going to line up the points of intersection between those two arcs, and we have another perpendicular bisector. So for the last, we're going to bisect UV, so compass point on U, open it more than halfway, draw an arc, keeping the same compass setting, turn it around, put the compass point on V, draw an arc. Where those two intersect, which is right here and right here, I'm going to line it up. And there we have our three perpendicular bisectors, and it says, what do you notice? And we want to notice that they are all concurrent. They intersect at one point. We call that the point of concurrency. All right, so that's number 6. For number 7, we're going to draw another triangle, GHJ, and we're going to construct the 3 medians of the triangle. All right, so for number 7, we're going to draw another triangle. One thing that's important here is it does say to draw, so we want to make sure that we're using our straight edge. The more neat our work is, the easier it is to construct. All right, we're going to call that GHJ. GHJ. Now, if I want to construct the median, we want to connect a vertex to the opposite midpoint. Okay, so if I want the midpoint, that means I need the perpendicular bisector, so I know where the halfway mark is. So again, I'm going to construct the perpendicular bisector of each side so that I can find the midpoint. So I'm going to find the midpoint of GJ, I'm going to open my compass more than halfway, draw an arc, turn it around, draw an arc. Now rather than drawing the whole perpendicular bisector, I'm just going to line up my straight edge with the 2 points of intersection and mark where the midpoint is on the segment. Okay. Now the median goes from a vertex to the opposite midpoint, so I'm going to line up H with my midpoint that I just found, and that's my first median. So to find the midpoint of GH, I'm going to put my compass point on G, open the compass more than halfway, draw an arc, keeping the compass setting the same, turn it around, put it on H. Then I'm going to line up the points of intersection between those. And again, I'm just going to mark where the midpoint is. So for the median, I want to connect J to the opposite midpoint. And for my last median, I want the midpoint of JH, so put my compass point on J, draw your arc, keeping the compass setting the same, draw the same arc from H. I'm going to line up those points of intersection, mark where my midpoint is. And then for the median, I want to connect G to the midpoint. And again, we see that all three medians intersect at one point, which again we call the point of concurrency, which will be helpful when it comes time for your project. All right, for number 8, we want to draw a rectangle PQRS, and then we want to use constructions to find the midpoints of each side. We're going to connect them and see what type of quadrilateral we have constructed. So for number 8, when I draw a rectangle, I know that the opposite sides of a rectangle are going to be congruent. So I'm going to make this 2 inches. And then I want 90-degree angles. So I'm going to make sure to measure out my 90-degree angles, because when I draw something, we want it to be accurate. We're going to measure out 3 inches along that path. And then I'm going to measure over in the other corner to make sure I have 90 degrees over here. And I'm going to measure the same length away 3 inches. And then, since they're each the same distance from the original side, we should have a rectangle just like this. Okay, so now I want to construct the midpoint of each side. So to do that, I'm going to, oh, I forgot to label, sorry. This is rectangle PQRS. PQRS. All right, finding the midpoint. Put your compass point on R, open it more than halfway, draw an arc, turn it around to come to point S, keeping the same compass setting. Line it up. And there's my midpoint. Next, I'm going to find the midpoint of SP, open it more than halfway, draw your arc, turn it around to point P, draw the same arc, line up the points of intersection, and we have our midpoint. Next side, PQ, compass point on P, open it more than halfway, draw an arc, turn it around, draw, no, don't fail me, draw the same arc, line up the intersections, here's my midpoint, and then for the last one, I drew mine a little close to the edge, so I'm going to do the same strategy as number 3. I'm going to put my compass point on R, open it a little bit more than halfway, draw an arc, turn it around, draw the same arc so I have that point of intersection right here. And then I'm going to do another set where it's a little bit further apart. And that means that both of these points should be on that perpendicular bisector. I'm going to line them up. And there's my midpoint. Okay, so now it says to connect all the midpoints. Midpoint to midpoint. Midpoint to midpoint. Midpoint to midpoint. And midpoint to midpoint. Okay, so we haven't talked a lot about quadrilaterals at this point in time. The most obvious shape looks like a diamond. I was talking to a couple students, and they said it looked like a kite. A kite is defined as 2 consecutive sets of congruent sides. But if you take a look here, we've got 1, 2, 3, 4. We have 4 congruent sides. So this is actually called a rhombus. A kite would have 2 different sets of congruent sides. A rhombus is where all 4 of the sides are congruent. A rhombus does not have to have equal angles. So we can see that these two angles are obtuse and these two angles are acute. Okay, so it's not a square because a square is not only a rhombus where we have 4 equal sides, but it also has to have 4 equal angles. So the best description of this quadrilateral would be a rhombus. There are definitions of quadrilaterals up on the front wall in the classroom if you wanted to take a look at them. All right, guys, hope this helps.